Hey, what's up, guys? In this video, I'm going to go through this Leetcode 380, insert, delete, get random, big O of 1. And this question was asked by Amazon, Facebook, and all other big names. So basically, this is an object design question. We need to design an object called randomized set, and you need to implement actually four functions. One is a randomized set, which is used for initialize the object itself, and insert a function allows us to insert a value to the set if the value is not already in the set, and also a remove function to remove the value from the set if the value is already in the set, and also get random function return a randomly chosen value from the set. And this is one of the key points. So we must implement all these functions have a time complexity of big O1. So immediately we need to use some sort of a hash set or hash table in order to do it. Otherwise, it will use a traditional array that would take a big O of n time when we retrieve the value. I will go through my function a little bit. Actually, we need to use a combination of a hash map or a Python dictionary combined with a list, and then that will allow us to use implement the whole thing by using big O1. So let's go through an example together. As we can see in here, we first initialize the object, we insert value of 1, and then we remove a value of 2, and it's going to return a false because the 2 is not in the set because we only inserted value of 1 at the beginning, and then we insert 2, and now the set contains two values. One is the 1, the other one is 2, and then we call the function getRandom, which randomly chose a value for us. And it could be, now because the set has two values, and they could be either 1 or 2. And then we remove the value 1 from the set, and now there's only a 2 in the set, and then we insert a 2 again to the set and remember that now 2 is already in the set, and then we insert it to it, and the function will not be happy because it's already in it. So that's why we return a false, and then we will call a function getRandom. And now remember that there's only one value in the set, and however we can randomly choose value from the set. There's only one option, which is the 2, value 2. So looks pretty straightforward for the question itself, but the challenge again comes from that we need to implement all the functions with a big O of 1. So let's see how can we do that. And we need to use a combination of a dictionary and a list. And the challenge of that is the list. When we insert a value in a particular index or remove a value from the list, and typically it takes a big O of n because we have to go through the entire list, and that's going to be slow and it's not going to be eligible for this problem. So a way to do it is to use the dictionary to save all the index, and then whenever we insert the value to the list or remove the value from the list, we can directly call that index, and that's going to save a lot of runtime. So let me show you what I mean by that. And so first we need to have a my index dictionary. So again, so the value being the value, the key being the value, and the value being the index. Let me try again. So the lookup key is the value, and the value being the index, which will be used in the value list because we have the index, and then we can directly use that index to look it up in the value list, and that's gonna save us a lot of runtime. And when we insert it, so if the value is already in the dictionary or in the value list, whichever it is, it's faster to just use a hash map. This is because the lookup is only takes a big O1. If the value is already in there as a key, and we have to return a false because there's no way we to insert it again. That's why we return a false. Otherwise, if the value is not already in the dictionary, and what we can do is to first create the index. So the index will be the length of the value list before we doing any appending to the list, right? Because, for example, at the beginning, the value list is empty, so the length of the empty list will be 0. So when we insert the value for the first time, the index will be 0. So the value will be whatever the value it is, and the index at the beginning will be 0 because the length at the beginning will be 0 because we don't have anything in the list yet, etc. And then we can create a second. The second index will be index 1, and the third index will be index 2, etc. Because it will be always look at the size of the list first before we append it to the list, and then what I said, we append the value to the list. So essentially, what it is, let me show you. I apologize for my drawing, but I think this is gonna illustrate. So the key, let's say the first time we inserted a value 1, and then the index is gonna be 0, because the length of the list will be 0 at the beginning. So we're creating the index, and then also the list will be looks like this, and then we have the value 1, and then we have value 2, and the index is gonna be 1, so it looks like this. So this is my index dictionary, and the one below it is the value list right here. So basically the inserting, which is whenever we insert a new value, we create a new index first, and then we append it to the list. And then the remove function, as you can see, this is a bit tricky. The way to remove it is to do this. So, for example, when we want to remove the number 2 from the list, so first we look at the last element, because the problem is when we remove a element, we want to keep the index of other element to be the same, so we don't have to change the dictionary, right? Otherwise, we have to change the dictionary for all the other elements index. So the trick to do that is to look at the last element of the list, and then take a copy of that, put it to the element that we want to remove. For example, in this case, we want to remove this 2, and then we take the last one, and then take this spot, and then becomes, so originally it's 1, 2, 3, 4, and then we want to remove 2, so we put the 4 to the spot of 2, so it becomes like this, 1, 4, 3, 4, and then we pop this guy. When you pop this guy, it only takes big O 1 time because the last element. Otherwise, we remove this one, it's gonna be taking big of n because we have to reassign all the values in the list. So that's why we can pop the last one, and then it becomes like this. So as you can see, when we have this list and compared to the original list, the 2 is gone, and this is exactly what we want. And also, we only take big of 1 of runtime. So let's look at how we can do that in the code. So first, we look at the last value, and then basically that's the last element of the value list. And then we look at, and then we save the index. So basically we look at the dictionary, index dictionary, look at the last value. And then we need to look at the index for the value that we want to remove. So we look at the dictionary and then save that in this variable. And then this is where we do the replacement. So remember, so this step over here is doing exactly that. So we putting the 4 to the second spot over here, right? So we take the index of the value that we want to remove, and then put that spot to the last value that we saved in the first step. And then, so now the value that we want to remove is no longer in the value list anymore. And now we want to update the one that we just moved its position. So we updated the index dictionary, and now its index will be the same index that for the one we just removed. And then now we can pop off the last element because it's already taking the second spot. We can just remove it, and that's exactly what it's doing over here. So it takes big O1. So as you can see, every step in here is just takes a big O1. And then now we can delete the value, the index for the value that we want to remove from the dictionary. So basically we taking here is deleting the index, and here we are replacing the value in the list. We are again here, let me try again. So here we are deleting the index in dictionary, and here we are replacing the value in the value list. And this is how we can do the whole thing in runtime big O1. So that is the remove function. And for the GetRandom function, it's kind of easy. So we can use this random log twice. So it's randomly choose a value from the list, and then we can return that. Let's submit it, and let's see how it works. So it works. Looks pretty efficient. So again, let me remind you of the runtime analysis. So time complexity, GetRandom is always big O1. Insert, delete both take big O1 in average. So I kind of go through this runtime analysis along the way when I was going through the code. And big O n in the worst case scenario when the operation exceeds the capacity or currently allocated array hash map. It invokes space reallocation. Yeah, this is some in the case when the memory is not enough to save that hash map, and then we have to relocate another space. And space complexity big O(n) to store n elements. And yeah, so this is so much for my solution. I hope you like it. If you do, please like this video or consider to subscribe to the channel. And hopefully I will see you in the next video. Thank you for watching. Bye bye.